Hi, I'm Grace and I'll be starting my group's presentation on the claim of if the car company's cars have a constant acceleration. Okay, so getting started. This is our lab of the claim analysis of constant acceleration. Our team is Nairi, Will, Mia, Rosa, Shane, and myself, Grace. So what exactly is the problem? So the problem is that a toy company made the claim that their pullback or pushdown cars demonstrate nearly constant acceleration. Our job is to determine whether the company's claim is accurate. So, our team is claiming that the toy company's car demonstrates nearly average acceleration during the trial for car number 40, but it is not accurate for car number 105. So, what experiment materials did we end up using? So, in our experiment, we ended up using 3 meter sticks, a roll of masking tape, 2 pullback cars, specifically number 40 and number 105, 1 marker, 1 foam to use as a camera, and 1 computer to use as a stopwatch, and then 1 chair to use to get our bird's eye view. So on this slide, we present all the materials that we did end up using with little numbers that align to the last slide so you can really visualize the specific materials that we did use.
Hello, my name is Rosa, and I will be discussing our group's experiment procedures for our setup and our trials. So to start off, for our setup procedures, we gathered all of our materials from the previous slide, and we laid our 3 meter sticks on the ground in a straight line with our centimeter side facing upwards. We then marked every 10 centimeter interval with a piece of masking tape, and then we placed a chair besides the meter sticks and had a person stand from there to record with a bird's eye view, and this person is referred to in the procedures as person 1. Then we placed a laptop within view of the camera, and we put a stopwatch, and the person in charge of this was referred to as person 2. Then we had somebody be in charge of pulling back and releasing the car at the 0 centimeter line, and this person is referred to as person 3. And a real quick note here that when we were looking at our data, we realized that the 3 meter sticks were unnecessary, so we are only taking data from the first 2 meter sticks, which is the first 200 centimeters.
Hi, my name is Will, and I will be going over the 3 different graphs for cars 40 and 105, as well as correlation of scientific principle.
According to the displacement versus time graph for car 105, this graph shows the position of the car over time. As you can see, the car reaches about 200 centimeters in 1 second. Based on the points on the graph, you can see that for any 2 points, the slope is not the same, which shows the velocity is changing. As shown in the velocity versus time graph, you can clearly tell that the velocity points are scattered at random throughout the graph. Since the velocity is not linear, this tells us that the acceleration is not constant. As seen in the acceleration versus
Time graph, the points are scattered above and below a horizontal line.
Similar to the graphs for car 105, the displacement versus time graph for car 40 is slightly slower. As you can see, at 1.25 seconds, the car is at about 200 centimeters. However, the relationship of the displacement over time graph for car 40 is similar to the graphs for car 105. The graph for car 40 is not linear, as the position does not change at a steady or constant rate. This means that the velocity is changing and not constant, as seen in the velocity versus time graph for car 40. Because the velocity is so random, this shows that the acceleration is not constant. For the correlation of scientific principle, the shape of the acceleration versus time graph shows that the car does not have a constant acceleration and that there is no correlation between the time and acceleration.
Hello, my name is Nari Balian, and I will be presenting the source of error in our experiment. When performing our lab, we noticed that there were areas where we struggled in that could have altered with our results. One being improper reaction time. In this instance, I had let go of the car without the timer starting. Another example would be any collisions throughout the trials. The car running into the meter stick interfered with our chances of collecting correct data. And lastly, when letting go of the car, we had noticed a trend. When we tested the cars, they would not go in a straight line. Some trials tended to make curves.
Hello, I'm Shane Musburger, and I will be presenting the rationale of our project. The claim that the car company made does not stand true for car number 105. During the course of our lab, we noticed that there were many instances where our acceleration did not remain constant. For example, at 0.2 seconds, the acceleration is approximately 200 centimeters per second squared, while roughly at 0.37 seconds, the acceleration was around 500 centimeters per second squared. Car number 40 also failed to meet the claim that the pullback car has a constant acceleration. Once again, we experienced the car slowing down as time increased.
Hi, my name is Mia, and I'll be presenting our next section of slides 28, 29, and 30, where I'll be discussing our CER, reasons our team excelled, and our reflection.
Reasons our team excelled. First, our team had an identical setup and means of measuring for both the cars that we were testing, and we utilized tools that we were familiar with from prior experience, such as creating graphs on Pivot. And finally, our biggest factor of success was the fact that we were able to honestly communicate about splitting the work, and we helped each other as much as we could. After performing our experiment, we learned that the two pullback cars did not have a constant acceleration and instead had varying accelerations. Rather than having constant acceleration, the test for car number 105 shows that the car had an acceleration of 500 centimeters per second squared at 0.37 seconds, and then had an acceleration of 380 centimeters per second squared at 0.57 seconds. For car number 40, we found that it had an acceleration of 175 centimeters per second squared at 0.58 seconds, and then an acceleration of 300 centimeters per second squared at 0.63 seconds. These results prove that all the pullback cars produced by this company do not have constant or similar accelerations, and that they can be faulty. For example, car number 40 tended to have a similar acceleration throughout the trials, while car number 105 experienced a decreasing acceleration throughout the trials. When it comes to reflection, we all learned the importance of detail. We learned that consistency is vital, and one slight error could alter results drastically. And we also learned the importance of communication and team effort.